Welcome back to another episode of Space Nuts, the podcast that is out of this world. And I am your host for this show. My name is Heidi Campo. I'm filling in for Andrew Dunkley.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us today, matching, we are both in black turtlenecks in case you guys are wondering, but is the wonderful Professor Fred Watson, astronomer at large. How are you doing today, Fred?
I'm very good. I'm basking in my black turtleneck. Yeah, it's kind of my preferred garment, is this, because it is so easy to put them off, take them off, no ironing, but they kind of get a bit too cozy when summer comes, so I have to shed my turtlenecks in summertime and go back to more conventional attire. So anyway, let's relish the thought that we're both from the same garment. So keep going.
Well, something that is not a black turtleneck, but is the black of space can roll into our first story of the day. And we do have a lot of really good stories for you today. If you're new joining us, we have 2 episodes every week. One of them is the wonderful Fred tells us all about the amazing new science that's happening in space, a lot of discoveries. There's amazing things happening all the time, and Fred tells us all about it. And then the other episode that we do every week is the listener questions. So you can write in your own questions and Fred will answer them. And so, yes, the black of space is what we are starting off with, and not just the black of space, but what's in it. And there's a mystery. Our first story is talking about the little red dots. And this mystery might finally be solved.
It's a great story because it's got lots of twists and turns. And one of the things I really like about it is that one of the co-authors of this story is Professor Avi Loeb, who is the, basically director of Harvard-Smithsonian Center for Astrophysics. His name usually crops up, Heidi, as you will remember, in contexts like this, speculating that interstellar comets and asteroids are, in fact, essentially alien spaceships.
Right.
And he opens our mind to these issues. And clearly a man with an extremely fertile mind, because this is one of the stories that is about a puzzle in the early universe. And sure enough, Avi Loeb is one of the co-authors. So we have a situation where the James Webb Telescope has revealed a large number of what astronomers call little red dots, and they're galaxies, but we're seeing them so far back in time because of the look back time. The James Webb is capable of looking back something like 12 billion years, almost to the dark ages before the first galaxies existed. And so these red dots appear red. That's partly because they're red-shifted. The light of them has been traveling for so long that the expansion of the universe has stretched the light waves and turned them from brilliant white into red because of the redshift and the expansion of the universe. So the galaxies we're talking about actually do date from that period, perhaps 12.8 or thereabouts billion years ago, when the universe itself was still in its infancy. And they're tiny, they're small, which is why they're called little red dots. But the curious thing about them is that they are unusually bright. They're very faint because we see them so far away, but intrinsically they are unusually bright, and that is a problem for the astronomers who observe them. Why are they brighter than you'd expect? And why are they red? one of the suggestions is it's more than just the redshift, that they might be shrouded in dust. That's one possibility, because as light passes through dust, it gets reddened, and that could account for that. But because they're bright, it suggests that they're not shrouded in dust. There must be some other reason, and there's several other conundrums that relate to this issue. And so what these authors have done is looked at perhaps the way that galaxies form in the first place. And we believe that the early universe had a kind of scaffolding, if you can put it that way, of dark matter, the mysterious stuff that we cannot detect other than by its gravitational pull. We call that the cosmic web, this scaffolding, and we think it's where galaxies form because the dark matter itself had this almost foam-like structure, and the dark matter acted as a kind of kernel, a seed for the hydrogen of the universe, because that's what the universe was mostly made of back then, apart from dark matter. The hydrogen of the universe sort of congealed, if I can put it that way, gravitationally along these structural lines in the cosmic web. And basically that's how the galaxies formed. But what they're suggesting is that the galaxies formed within what we call dark matter halos, the halo around a galaxy that is the dark matter structure. And those halos may well have been rotating. And it turns out that if you form a galaxy inside a rotating halo that is spinning relatively slowly, what it does is it compresses everything in the middle. The press release that I've read actually draws the analogy of a fairground swing ride, where you've got a fairground roundabout carousel with chairs on it that swing outwards as the carousel rotates. The faster it goes, the more the carousel chairs swing outwards. And so what they're saying is, if you've got the analogy is that if you've got a spinning halo, then the faster it spins, the more space you've got for the stars to form within it. But the slower it spins, the less, in the carousel analog, the chairs are inwards, and for the story of the dark matter halos, it means that the slower they spin, the more compressed the region of space within them is, and so it keeps the stars much more closely tied up together, the stars that are forming within the galaxy. And that is what they say is a possible mechanism for giving you these really compact little red dots. I'll quote from this. The researchers discovered that the little red dots likely formed in dark matter halos spinning so slowly they represent less than 1% of all halos in the universe. Their slow spin halos would naturally create extremely compact galaxies in a hypothesis that elegantly explains several mysteries about the little red dots. And I'm quoting there from Mark Thompson's article in Universe Today. So yes, it looks as though these little red dots that have so far been one of the big mysteries uncovered by the James Webb Space Telescope, it looks as though here's a step in the right direction to try and prove what the reason for this is. That they are, as the same article describes, wonderful natural time capsules, and perhaps there's a possibility that they might tell us more as we study them in greater detail. They might tell us more about this time in the universe when the first galaxies were forming, the end of what we call the Dark Ages, a really interesting time that we don't really understand all that well at present. So I think it's a step in the right direction, Heidi.
Yeah, but I mean, well, that's why I love James Webb Telescope. It's really, it's such a feat of engineering, and it's discovering, like, I feel like every almost every week we could have a story with James Webb and everything going on with it. And that's really, really remarkable.
Time to take a break from the show to tell you about our sponsor, NordVPN. If you're online, your data is always at risk unless you take some sort of action to secure your exposure. And a virtual private network is the way to go. There are lots of hackers and trackers and unsecured networks out there that just make you an easy target. And it happens without your knowledge. It always happens very quietly and in the background. And that's what makes it so nasty. And that is also why using a trusted VPN like NordVPN is a pretty smart move. NordVPN keeps your internet connection secure and private by encrypting your data and hiding your IP address. And that means you can browse, you can stream, you can shop, you can work online without worrying about who might be watching. It works seamlessly across all your devices, and it is one of the fastest VPN services available, so you won't sacrifice speed for security. And right now, as a Space Nuts listener, you can get an exclusive offer, big savings on NordVPN plans. If you go with the 2-year plan, you get an extra 4 months for free. That's 28 months. And all you have to do is sign up. Don't forget, they've got a 30-day money-back guarantee, so you can test this out for yourself before you fully commit. But I've been using it for years now, and I've got no complaints. So go to nordvpn.com/spacenuts, nordvpn.com/spacenuts. Take control of your online privacy today. Easy to use, powerful protection, no hassles. nordvpn.com/spacenuts. And don't forget the code word spacenuts at the checkout. Now back to the show.
Roger, you're loud and clear here also.
Space Nuts.
And speaking of remarkable, there has been another amazing story about kind of a breakthrough. But before we say that, I forgot to make a very special announcement. And Fred knows what it is. Andrew knows what it is. Hugh knows what it is. But do you guys know that because of you, we have been ranked the 7th astronomy podcast? And Fred, that was worldwide?
Yeah, that's right. It's in the top 50. So we're number 7 within the top 50 of astronomy podcasts. Yeah, I'd forgotten that.
I know. I should have said it first thing. So I was thinking of amazing, incredible things. And I was like, we should bring that up. So thank you so much, everybody, for listening and telling your friends and telling your coworkers and telling your pets and dogs and your in-laws to listen to the nuttiest space podcast that there is. So thank you guys. Really, we really appreciate that. We should do maybe Fred, we should do like a special listener episode where we jazz it up a little bit as a little thank you to everyone for putting us on that list. But our next story is also an incredible breakthrough. For the very, very first time ever, we have the first female Astronomer Royal, and that is Michelle Doherty. And that is quite the accomplishment.
Oh yes, it's a great story, and congratulations to Michelle Doherty, a scientist of great note. She is somebody who has made basically astronomical advances across quite a large number of fields of study. She's actually principally a planetary scientist and works on some of the NASA spacecraft missions, and is very interested in going back to Saturn with robotic spacecraft. She was principal investigator for the magnetometer, which was on the Cassini mission, which I always think is one of the most accomplished remote sensing missions ever mounted. NASA and ESA combined on that mission. Sadly, 2017 marked the end of it, but we learned so much about the planet Saturn and its moons and its rings that we're still analyzing the data. And Michelle is also principal investigator of the magnetometer instrument for the JUICE mission, the European Space Agency's Jupiter Icy Moons Explorer. So lots of amazing accolades for Michelle. Just to put her achievement in context, she is the 16th Astronomer Royal in the United Kingdom. This is a post that had its first Astronomer Royal in 1675 when John Flamsteed was appointed by King Charles II was the Astronomer Royal, who was going to sort out the problem of longitude, which was then the big issue. And he did quite a good job with it. There's lots of stories about Flamsteed. But since then, there have been 16 Astronomers Royal. Until 1972, the Astronomer Royal was also the director of the Royal Observatory at Greenwich, and that was founded by Charles II in 1675. I worked there twice, in fact. It was at a little tiny village called Hurstmonceux in Sussex. It had moved away from Greenwich, which is a suburb of the city of London. No chance of doing astronomical observations there. They moved to Sussex after the Second World War. I worked there for a while in the early 70s, and then I went back there in the 90s to work, by which time it had moved to Cambridge in eastern England. But until 1972, the director was also the Astronomer Royal. After 1972, the two positions were separated. The director of the Royal Observatory was not necessarily the Astronomer Royal. The most recent Astronomer Royal, and the person who Michelle succeeds, is, he was Sir Martin Rees. He's now Lord Rees of Ludlow, a gentleman based in Cambridge. I've met him a number of times. He certainly wouldn't remember me, but I've come across him in my career. He has been Astronomer Royal for basically 30 years, since 1995, and has now stepped down and his replacement is the first, as you said, the first female Astronomer Royal in its more than 300-year history. North of the border between England and Scotland, however, they are ahead of the game, because Scotland also has an Astronomer Royal.
Oh, okay.
Known as the Astronomer Royal for Scotland. In fact, one of them, I think he's 2 Astronomers Royal ago, was my PhD supervisor.
Oh, wow.
Professor Malcolm Longair. So I had an Astronomer Royal for my supervisor. It was a terrifying experience, I can tell you, Heidi, because his brain was the size of a planet and mine wasn't. But anyway, that's all right. We got on fine. He's still going strong. He's in Cambridge now, no longer Astronomer Royal. But
he helped shape you into the Titan that you are today.
Oh, that's a very nice way of putting it, and I'll take that and wear it with pride. Thank you very much, Heidi. The current Astronomer Royal for Scotland is Catherine Haymans. And she's been Astronomer Royal for Scotland for, I think, about 4 years now. So Scotland was in the lead when it came to female Astronomers Royal. The other reason that I love this story is because when I was at school still, I aspired to be the Astronomer Royal. And it didn't happen. But there was a kind of equivalent in Australia for a few years, the Astronomer at Large. And that was me. That is the job I held until the end of last year. So it was a sort of quasi-Astronomer Royal that I finally got to, but not the Astronomer Royal as such. But it's very nice. I had quite a lot to do with Catherine Haymans, the Astronomer Royal for Scotland. We've communicated quite a bit. She gave a fantastic lecture for us a few years ago online during COVID. And so, yes, the idea of an Astronomer Royal and a new one is great. And I think it's brilliant news all round. Maybe, Heidi, one day you could aspire to be the Astronomer Royal. I'm not sure whether you have to be a British citizen or not. But
I think, well, right now we're thinking about having a double master's degree. So I'll take these things one at a time.
Yeah, good on you. That's great too. Great stuff.
It's just a lot of work.
0G, and I feel
Space nuts.
But I have no clever segue for our next story, so I'll just start telling you guys about it. And it is quite exciting. I know everyone gets pretty excited. I know I certainly do when we talk about the possibility of life on other planets, but signs of life on Mars can be detected using this new test that Fred is going to tell us all about.
Yeah, this it's a really interesting story. I mean, this is on the topic basically of biomarkers, which we've talked about before. And biomarkers are things that tell you that there are life processes going on. And so, for example, with when we look at the atmospheres of planets around other stars, extrasolar planets or exoplanets, we look for chemicals in the atmosphere that might be only produced by living organisms. And, if you find that and you're sure it can only be produced by living organisms, then it's a sign of life. It's a biomarker. It's very controversial, as we've discussed, because there's always a question as to whether there could be a purely chemical origin for life in the atmosphere for these chemicals in the atmosphere of another planet. That's an aside here, because what we're talking about now is how you might analyze the structures of molecules that you find not in the atmospheres of exoplanets, but on the surface of a planet like Mars. Mm-hmm. And it turns out that some work that's, again, been done in the United Kingdom, there is an instrument which is commonly used on Mars rovers. In fact, I think every Mars rover since the Viking landers, or every Mars lander since the Viking landers, have had one of these things. It's called a gas chromatograph mass spectrometer, usually abbreviated to GCMS. Gas chromatograph mass spectrometer. It's a lot easier to say GCMS. Mm-hmm. They've all got one of these things. Okay. But the suggestion that's come from Imperial College in London is that we're missing a trick, that there is something within living organisms that people haven't really thought of, but that it could be detected by this GCMS. And what it is, it's a chemical bond within the molecules of cell membranes, living cell membranes, which I think are made of lipids and things of that sort. I'm not a biologist, so I'm always groping around here. But the membranes of living cells have these molecules within them that apparently give a signal when analyzed by the GCMS.
Oh, wow.
That dies away when these creatures are no longer alive. So the signal disappears after an organism has died. It's the chemical bonds that the GCMS is detecting, and those bonds are actually, they disintegrate on death. They're called, the bonds themselves are called, the molecules in which these bonds are found are called intact polar lipids, or IPLs. Yeah. And IPLs show up when they're analyzed by one of these GCMS instruments, but they disappear when that microorganism dies. So here you've got a really cluey and pretty neat test for living organisms that could actually be deployed now, because they're on Mars already. I don't know whether this paper has basically set all the NASA mission scientists who are looking after Curiosity and Perseverance into a panic of making sure that they use these instruments to analyze the molecules that they've already got. They've got samples of the rocks, and it could be that there might be living microbes within those rocks that could be detected by this. So my counsel is watch this space. The science paper is entitled Intact Polar Lipids as Organic Biomarkers of viable extraterrestrial life, and it's in the journal called Space Exploration. That's the place to find it. It's a really interesting idea, and who knows where it might lead, Heidi.
Who knows indeed. But one thing we do know is that Musk's mega rockets keep exploding. This is the one thing. He's such a Musk and SpaceX, whether you love him, whether you hate him, is an interesting character on the board. And they keep pushing the envelope, but there's these new tests that Fred's gonna tell us about.
Well, that's right. In fact, by the time this episode goes to air, it might already have happened. But this is the 10th launch of the Starship, and I think, well, you know, I'm not going to go through the catalogue, but they've been less than successful. Some of them. I think the first one was brilliant because it demonstrated that the booster, which is the Falcon Super Heavy booster, could be captured by this. It's called a chopstick mechanism, I think. It's like a pair of chopsticks sticking out from a tower, which catches hold of the vehicle as it lands.
And
that was
stunning.
dramatic.
I think that's
it's unbelievable.
I think that's almost like Nobel Prize worthy. Like that is, I think, one of the best feats of engineering in this decade, for sure.
Yeah. In an era where we've just got used to the boosters returning, and that's because Musk pioneered that with SpaceX back in 2015. I think the first successful booster landing took place, the first time ever. But yeah, this gigantic thing, you know, it's a huge, huge rocket. The whole thing stands much taller than a Saturn V from the Apollo era. But the booster itself is a good part of that. And that they seem to have that kind of reasonably well under control, but it's the Starship itself, the thing that rides on top of that, which has kept exploding, or what's it called? It's a rapid unscheduled disintegration.
Yes,
I think is the rapid unscheduled disassembly.
That's the controversial
That is
statement. I think it's kind of cheeky, though. It's you know, it's a little optimistic. It's a little cheeky. It's like, hey, you know what? We're going to keep working on it. You gotta
You
have
can afford to do that.
You can't afford.
Yeah,
to do
you
that.
do. But his whole ethos is, test fast and learn fast, and you can do that without all the protocols that would have to be in place if this was NASA actually running this rather than a private company. So hats off to Musk for number 10 in this sequence of launches. By the time this goes to air, we might know what has happened. We don't at the moment, but we'll look forward to the event with great interest.
Well, I'm hoping it's successful.
Me too.
For all the engineers' sake, for everyone on that team, it's got to be so heartbreaking to pour your heart and soul into a project and just not only to have it blow up, it blows up on TV and then everyone writes an article about it. It's like, oh man, it's like if I get a bad grade, nobody knows. But if they make a mistake, it's a dramatic explosion in the air that everyone in the world has their eyes on. So I hope it goes well. Thoughts and prayers to the science team, the engineering team, and hoping for their success.
Yep. Here. I'll agree with that for all the same reasons. It's one thing that we want to see succeeding. In fact, Starship itself is an integral part of the Artemis mission because the Starship, the crew component of that is what is going to take astronauts down to the lunar surface by 2027. So they've got to get it right within the next couple of years.
What do you think? Do you think we stick with 2027 or do you think it's going to get pushed out?
It'll get pushed out.
I think it's going to get pushed out. I want to believe, but it's like one of those old Magic 8 balls. It's like signs don't look good. I've had a little bit more of experience now working adjacent to NASA. I want to be clear on air that I don't work at NASA, but I work in partnership with them with some of my graduate assistant work. But it's really just, and like you said, Fred, it's the loopholes, or not the loopholes, it's the hoops that you have to jump through. There's so much, there's a lot of red tape. There's so many layers of safety that NASA has to go through that just makes them run a little bit slower. So things aren't happening as fast as the public would want. They're not pumping out progress the same way Disney's pumping out Marvel movies.
Yeah, that's right.
Well, this has been a great episode. We got through 4 whole articles. A big thank you to our listeners and some speculation of the future. So we were quite efficient in our use of time today.
That's why we're number 7.
That's it right there. Best podcast out there. Tell your friends.
Yeah, absolutely.
Well, everybody, thank you so much for listening to the number 7 podcast, number 7 astronomy podcast. Wow, if we were the number 7 podcast, you'd probably see a fancier background and headset. But no, thank you so much to our listeners. You guys really are fantastic. And please keep writing in your questions. Do audio questions. We really want to hear from you. You guys are half the show.
Absolutely. And some might say the best half of the show.
All right, everybody. Well, we'll catch you next time for that very, very own Q&A episode. Till next time, have a great space exploration, discovery, and
see you next time.
Hello, Heidi. Hello, Fred. Hello, Hugh in the studio. Andrew again with another World Cruise update from the Crown Princess. Since I spoke to you last, we have done some amazing stuff. We visited Iceland and Greenland. Fantastic. Iceland was amazing. We did a day trip out to a place where the now let me think if I can get this right, the Euro-Asian tectonic plate crashes into the American tectonic plate. And there's actually a rift valley right there that you can literally walk along in one part and see how the European side's been thrust upwards, the American plate goes down underneath. And they do have earthquakes there semi-regularly, but thankfully not while we were there. But what an amazing sight. Saw some incredible sights in Iceland. I was actually quite surprised how green it was. I was expecting just rock and volcanic outcrops, and I'm sure that's there. But where we went was actually green. There were farms, there were paddocks, there were horses and sheep grazing. Not at all what I expected, but a fantastic day. And we were there for the Pride Festival in Reykjavik, so we hung around the city for a little while after our tour and just absorbed the atmosphere. Quite amazing, just thousands upon thousands of people. They reckon there were about 100,000 people there the day we were there, and our ship was in port, so we added a few thousand to the mix. That was Iceland. Loved it. Then we trotted across to Greenland, and our captain decided at the last minute to take us on a little tour up the sound known as Prince Christiansund, and it was a day of just cruising up the sound, looking at multiple glaciers up close, icebergs everywhere, just this beautiful untouched landscape that very few people get to see. So we were thrilled to do that. Then we landed in Iceland at Nanortalik and spent the day there, went out on a boat to look at more icebergs, but this time we got up close and personal, and they were huge, like twice as big as double-storey homes in some cases. They were just, and they were just floating there. We got so close to them. We didn't quite get close enough to touch them, but you could see the colours and the cracks and the shapes of the ice. They were amazing. And a lovely little town, only 1,000 people. Greenland is about 1/3 the size of Australia, with a population of less than 50,000, and it's under the Danish monarchy. So it's a sort of a crossover between America and Europe, really, because it is considered part of the American side of the Atlantic, but it's a European country, self-governed under the Danish monarchy. It's very weird, kind of like Australia. But that was interesting. And then yesterday we went to I can't think of the name of it. What was that place called yesterday? Quackertock. It's about triple the size of Nanortalik, but and all these colourful little houses. I did post some photos on the Space Nuts Facebook page if you want to have a look of the icebergs and the little houses. I don't know how they live in them. It's summer here at the moment, and the temperature was 6 degrees. And it was freezing for the 2 or 3 days we were around Greenland. Iceland wasn't so warm either, I must say. But we're heading southwest now, and our next stop will be Halifax, and the temperature will be about, 5 times warmer, I'm told. So that's it for now. Only a couple of weeks to go, and we'll be back in Australia. I should just point out we sold our house while we were on board, and we're moving into a new place that we haven't seen yet. So I don't know what the internet will be like when we get back. I might have to delay my return to Space Nuts for a week or two, but we'll just see how it goes. For now, that's all. Take care. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.